In this one, we need to actually be slightly more creative. We have to construct a reduction formula for this integral. Okay, that's harder. Now, at the heart of the method for constructing these reduction formula is integration by parts. Okay, integration by parts will get you, hopefully, a reduction formula. All right, so let's discuss this and analyse it in detail and see where we go. So here I'm just interested in the case n greater than or equal to 1. Okay. All right. Integration by parts. We need to make a choice. Integration by parts. So with integration by parts, I need to assign, say, u and v dash to parts of our integrand. Now, in this case, I'm going to let x to the n be u and e to the x be v dash. Can anyone sort of suggest why I've made those choices? Why didn't I switch them around?
Because once you make u to be x power n, then if you take u dash x power n will reduce by 1.
Good. Yes, exactly right. There is a method, or I guess a reason for this choice. These are called reduction formulae. So in other words, we want to spit out some sort of formula for I sub n where the powers or whatever, subscripts, whatever, are something like n minus 1 or n minus 2. Now, if we let u equal x to the n, the derivative, u dash, will be n times x to the n minus 1. So we've reduced the power by 1. Okay? Important. Very important. All right, so if we work out the, n times x to the n minus 1 and v equals e to the x. All right, so let's use our integration by parts formula and see if we can construct this reduction formula. Now, I've been a bit naughty. Oh, actually, no, it is an indefinite integral, so that's okay. So let's substitute in and see what happens. U times v, x to the n, e to the x, minus the integral of the two things we just thought up. Okay, well, big deal. We've done an integration by parts. Who cares? Anybody want to suggest what we can do now? Huh? What? You said what? Oh, you could integrate the second part, but do we need to? Well, if you look closely, what's this compared with this? Well, it's almost the same, but not quite. I can move this n out because we're integrating with respect to x, and it's actually I sub n minus 1. Okay, so just pull that n out, and then you've got a n minus 1 in the power. So my reduction formula is the following. That's it. Now you may be able to, let's say I switch those choices of u and v dash around. It probably still would work. Okay, you'd probably still get your reduction formula, but you'd have to be slightly careful.